In this webinar meeting, we are happy to have Mr. Ralph Steubing from Germany with us. He works at ICL, a multinational company specialized on fertilizer. As crop nutrition is an important topic in agriculture, you might be interested to learn more about it, especially if involved with the design and planning of solar-powered irrigation system. Today, Mr. Steubing will tell us a bit about his work in general and what a rural smallholder farmer has to keep in mind if interesting fertilizer on his or her farm, the so-called fertigation. In the first part of the webinar, Mr. Steubing will shortly present his work. In the second part, I have the opportunity to ask him some questions. My name is Bernhard Hollemann, and I hope you will enjoy your webinar.
Thanks, Bernhard, to join you at your webinar. Ralph Steubing joined the ICL company more than 20 years in the past. I'm responsible in Germany for fruits, vegetables, and some arable crops. And I developed some programs for feeding with products from ICL. To introduce you, what is ICL? I'd like to share some pictures with you. ICL is a company more than 60 years worldwide acting. We will harvest and mine raw materials. Mostly it's potassium, phosphorus, sometimes magnesium, and some also microelements. We'll also do it in other countries worldwide. And then you can see mining in Spain, where we have mostly potassium chloride. This is a normal compound granular fertilizer. So from this raw minerals, ICL is producing compounds and granulatize magnesium, phosphor, and sell it as, let's say, as normal compounds and sometimes semi-specials when we do special mixes of orthophosphates or phosphates with potassium or with traces. So we develop from a normal compound water-soluble fertilizers, which can be used for fertigation, for foliar application, or we can produce coated material as well, which sometimes, especially in vegetables in Africa, is well known. 2017, nearly 12,000 people worldwide are doing the work for the ICL company, and we from specialty fertilizer, we organize the world in 3 regions. So I'm responsible for the German and European market, but in my division, we also do the work for the African continent and for Middle East. From our brands, we have also foliar products, and we will today but talk only in the products which are water soluble, so which you can use in drippers. And we produce also NPK water solubles as well. We also are a very important player of straight fertilizers, which is calcium nitrate, potassium nitrate, or monoammonium phosphate, MAP or MKP, mono potassium phosphate, which is the most common straights worldwide.
Thank you, Ralph, for your interesting presentation. I'm sure that there are some more additional questions. As I understand, you can tell us a bit more what you consider as a best practice to fertilizer crop using solar-powered irrigation for farmers as well as smallholders and peasants. To start with, I would like you to tell us a bit about the best feeding method for fertilizer application, inclusive the technical equipment. Thus, the tools to apply fertilizer to crops have a significant yield and quality response.
I prepared for this webinar some steps which you have to follow up to find the best method to apply fertilizer, even in a drip irrigation system. To find the proper way, we have to go for certain topics. To be having knowledge about my plant growth behavior. So every crop has certain stages from if it's a sowed plant or it's a young plant which is planted outside. So we have to know about the time of the year where we will go outside and start our production. We have to know about the growth behavior in detail. So it is a crop which have a high initial end release or demand. So we have to know a little bit more than just about the expected yield and the usage of the product. If we are not in a protected area or in substrate, but in soil, in open soil, we have to know a little bit about soil chemistry. That means certain chemical or physical topics which you have to measure or to know in advance. This will have an effect of the availability of the nutrients which we will apply or which we also already can found in the soil. When we like to combine a granular or a compound fertilizer with an NPK or with straight, which we'll apply in the feeding with drippers, we have to define how many % of granular we will apply in advance and what we have to fill up to certain stages during the growth stages. To find the right fertilizer means first we have to check the water quality, because a lot of ingredients in the water can harm our drip system or drip irrigation system and can cause blocking effects. Last but not least, you have to take care that when you use a fertilizer which you will solve in a stock solution, you have to take care that not everything is possible and that depending on the ingredients in the water, you have to choose the correct fertilizer. So, but first, let me give you some sentences about general aspects. When you will try to do something better with drip irrigation, it's always necessary to define what you like to do and to do better. Fertigation is a different method to apply nutrients. And if you're doing it correct, it allows you to apply the nutrients in an exact and uniform way into a rooted zone where active roots are more concentrated and where the effect of applying water and nutrients is doing a quick and better response of the crop. So we can adapt the amount and the concentration of the nutrients much better than using a broadcasting system. And we can easily adapt to certain steps in the growing season the balance between nutrients and the total amount of nutrients which we apply in a certain time. And in order to make a correct planning of all the nutrients which we will supply, we have to know about the physiological stages of the crop, and we must know something about when the crop needs what. So there is a growth curve which have different demands of NPK, magnesium, calcium, and of course traces. So we need the daily nutrient consumption rate to follow up this growth curve and to feed the crop on the best way. And if we do it correctly, we can increase the yield, we can increase quality of the crop, and at the same time we can go down with the total nutrient demand per hectare, which will save cost. You have to combine or to differentiate between a traditional method of applying fertilizer and a quite modern system with fertigation. In former times, or also worldwide, you can find it on certain places in the world, that you will throw with a Düngemulle, a fertilizer, a compound by hand. So this is very roughly a method which you can use, but it's not really correct. You never know the exact amount per square meter or per hectare. So you have, in most cases, a much higher demand, which you consume of fertilizer. And if it's a nutrient that is not keeping in the first active root zone, you will waste fertilizer and you will pollute the environment. A modern and better idea is to use a spreader behind a tractor. You can use machines which are doing broadcasting and throw, let's say, 15, 18, up to 32 meters. Or you can use, which is also possible, a raw applicating. That means you will not throw with a disc. You will use instead a pipe, and then you will go and give it direct close to the crop in a row. Or if you will try to combine, you can use something to solve a water-soluble fertilizer, and it's the first difference between compound fertilizer and a water-soluble, because in the production process, you have to decide if you want to produce a water-soluble product that is really has to solve quickly and completely in the water, and then you can prepare a stock solution, or you have much cheaper products which is not solving in a stock solution. When you will try it, you have a big precipitation on the ground of your tank. This is not possible to use for fertigation. When you will use a water soluble, you need some technique to dosage your stock solution to your crop. You can use a passive system, which you have here on the left side. On the top left, that is a proportional doser, which is just functioning from water is going through this unit, and by a certain amount of water which is going through this dosage unit, you will have a couple of seconds, one step of applying a stock solution to the water, and then you will create your solution with having a certain amount of fertilizer. So you will produce with such a unit a feeding solution, which is giving the right product with NPKs to your crop. This is a product which you can use for a limited amount of water per hour. In that picture, you will find a product which is only used for 8 cubics per hour and hectare. So it is for, let's say, just adding some water-soluble fertilizer to a base fertilizer system with granulars. Or you can use something like that in a bypass system, which is in the lower left picture. That is a Venturi pump. Venturi pumps are using the effect of high pressure and high speed watering in the small pipe. With the system is using under steer product. That means the possibility to apply fertilizer to big water volume. So in the installation on the lower left part of this slide, you have 40 cubics per hour. In maximum, you can use 80 cubics per hour. So with such a dosage unit, you can apply without any problem for up to 10 hectares in one setting. But it's not quite correct. So in such a case, you can apply a certain amount of kgs to a hectare, but not exact nutrients in milligrams per liter, because it's not possible with such an installation. So for open field, it is not common to use. You will find such installations more on greenhouses. A practical installation could be the energy from solar panels, and even the wave to open and close your pipe can be done by the solar power. You need pressure waves to limit the pressure in the drip line. You need your proportional doser, and you need some extra installation like a pressure relief valve to check that the pressure is on the correct way. You need, in most cases, in such an installation, let's say 1.5 up to 4 bar in your fertigation drippers. And in some cases, if you use a product which is having pressure compensated drippers, you can use between 1 and 2 bars. So this is not a high installation degree, so you can use an easy product, and you can use for exact dosaging a product like that.
So thank you very much, Mr. Steubing, for the very comprehensive answer of my first question. Now I would like to point out to ask you a second one, and that will be how to calculate the right amount of fertilizer based on the available data, and which is the best method to apply fertilizer, being a farmer or peasant in Africa using first time a solar irrigation system, and B, when does fertigation make sense and what are the limits?
Okay, to calculate the correct nutrition program, you must collect some infos about your crop demand, the soil substrate, expected yield, and water source. So you have to take care about all the different factors you have to produce crops. You need from the crop the nutrient requirements, you need soil chemistry, fertilizer chemistry, water quality, and the behavior and the reaction of the crop. When you will divide between greenhouse and open field, we have to use substrate or in soil, so you need to know about a little bit about soil chemistry. So when you will have a close look on your soil, you will find 100% of the soil is divided in 50% of solid ingredients, so it's minerals, 25% in most cases it's liquid, and 25% is gas. That means even oxygen in the soil, which is a must. And of course, you will find different particles in the soil. And this gives you an indication about also the nutrients. And which you can do is to measure some parameters to have a close look what you will find for a type of a soil. You can measure easily the pH value of your soil. You can measure the EC content. That is a tool to investigate about the salt content. If you're able to check the cationic exchange capacity, you have an instrument to find how many nutrients we will find, and then you can check the soil type, if it's more loamy or it's clay or it's a sandy soil. And depending on your soil type, you have certain values or levels of nutrients which are used to have, and which is best not to oversteer, because this will have an effect of losing nutrients to deeper zones of the soil. Because nutrients in the soil can move. And if you have a more sandy soil, it is even faster than when you have some clay or lime in the soil, because even lime or other clay particles can keep the nutrients in the upper part. So even nitrate will follow up the movement of the water quite easily. So if you apply too much nitrogen in a soil which is having more sandy type, you will lose a part of the nitrogen which is not available and will not react to crop growth. So take care when you have a more sandy soil, don't oversteer your nutrients per week or per treatment. And even the pH is having an effect of availability or of effects of the development of root and leaves of the crop. In most parts of the world, and in Africa, we have high pH values, which having, of course, an effect of less availability of even phosphorus and a little bit of nitrogen. And of course, also traces will have a negative impact. And improving to high pH values gives you a nice positive reaction, even of the availability and of the consumption of nitrogen.
Thank you very much, Ralph, for the very interesting second part. Now, please, we are looking for the third questions, and this will be as followed. How to calculate the best fertilizer mix using granular and liquid for fodder, for foliar, or for drip? And A, what is the right amount of each crop stage? And B, what fertilizer strategy is simple to use for drip irrigation?
To find and to calculate the best feeding scheme, we have to follow up a certain procedure. If we define a combination of granular based fertilizing and then just add some fertilizer, is different from applying all nutrients to the dripper. And depending on the crop cycle and the time between planting and sowing and picking, you have to define which product you like to use. If you find a water source which is having very tricky conditions, it's better to split the applications in more time zones to follow up a certain growth stage or growth curve and the demand of the crop. In this slide, I show you for some vegetables the different consumptions of nutrients in daily consumption from the start of the crop cycle to the picking time. And you find a different NPK ratio from start up to the end of the crop cycle. And to know this means that you can adapt the NPK ratio in your stock solution. And if you try now to do it with a combination of granular and water soluble, you just apply the minimum that is in, let's say, the tomato industry, that is a foliar protected production. You will give up a certain N demand, let's say 1 kilo per day and hectare, and this multiplied by 100 days, so 100 kg you will give in the first stage by planting, and then just add the necessary N in the feeding, in the drip line by day. If you try to do it directly 100% with the feeding product in the drip line, then you just measure the NPKs which you will have in the soil by a soil analysis in advance before planting your crop, and just add what you need as the difference between what you find in the soil and what you have to apply by the different weeks. If you have a very salty water, please take into mind that you have a zone in the soil, and this zone is always coming up more and more to the surface, where the salinity is having a high impact on your root zone. So in cases of very salty water, it's always appreciated to give a high and frequent supply in your dripper with just water. So you have to divide between fertigation and irrigation to wash out all the salinity zone in the first 30 up to 50 centimeters of your soil. When you will prepare a stock solution, take into consideration that it's quite difficult to use when you have a hard water and you will apply fertilizers which having sulfates, urea or phosphorus, that you will have interactions between the products. If you have hard water and you will put a product into it, a fertilizer which having a high content on sulfates, you will have precipitation with calcium sulfate, which is not water soluble. The same effect you will have with just applying urea to hard water in a stock solution, which having calcium carbonate. And the third effect is that always a lot of phosphorus products like MKP or MAP will into hard water react to water not solvable products with calcium, magnesium, phosphorus. The same effect can happen when you will do the same with potassium chloride and ammonium sulfate in the same stock, or phosphate or sulfate with calcium nitrate, or magnesium sulfate with MLP or DAP. So in such a case, it's better to have not one tank, but use a two-tank system. So not only one barrel, but install 2 barrels and use 2 dosatrons. More detailed, we can try to find out what is the best feeding method when you will apply fertilizer. We divide into 2 time zones in the year. If we are in a spring or a winter time and we have cold temperatures, we will divide of if we have an open field production or we are in protected areas like tunnels or greenhouses. And of course, when we have a different soil types about pH, we have to divide and to use the right N source to go to the crop without any harming the crop or disadvantages. So in cases of an early spring or winter crop, in open field with a low pH, we use no urea, so we have to use an NPK or a straight-based system with having only nitrate as N source. If the pH is high, we also try not to use urea because the reduction from urea to ammonium and nitrate is reduced under such conditions. Then you can use ammonium or you can use nitrate, but then it's appreciated to reduce the pH of the soil and break down the bicarbonates using phosphorus or nitric acid. When you will have not an open field production, but tunnels or greenhouses, we have to divide between soil and substrate. In cases of soil, again, use a product with having more nitrate and not ammonium or urea to have a better reaction. If it's covered in substrates, in baskets or in containers, then it's appreciated to use nitrate, because otherwise you will have a bad reduction from ammonium to nitrate, and you have a possible cause of damaging the roots. In cases on summer production, then it's a little bit easier. In summer, so under warm conditions where the reaction and the activity of microorganisms is quite good, in open field, we use in low pH soil conditions all available end sources on the market. So then it's more to know if the chloride sensitivity of the crop is huge or not. If the chloride is not having a negative effect, you can use a product with having potassium chloride as a base, or you can use potassium sulfate based product. When you have not a low pH, but you have high pH in calcareous soil, then you can use very good ammonium or urea. And then you can use a product with having phosphorus acid or nitric acid, or you can apply as well ammonium as an excellent tool to steer the product and have a good reaction on the crop. In tunnels or greenhouses, you can use more or less the same scheme. In soil, you can use all end forms which are available in the market. In substrate, again, take care, because there you have a less content of microorganisms. Then it's better to use a nitrate form, because then you have an immediate effect and reaction in the leaf.
Thank you very much for the third part. I'm very glad to get such a good, impressive information, and really I learned a lot. Now I would like to switch to the fourth question, and that will be how to check and measure for an optimal fertilization due to crop development, weather, and climate conditions. A, what measurements and checks are useful and adequate for irrigated fields? And B, what results can give us soil and leaf samples?
When you will decide for a feeding scheme, it's always appreciated to follow up and to do accompanying examinations. What do you have to use and what to check? The best technique will not help to produce a good crop, even not if you use high quality fertilizer, when you will not have a daily or a regular visit to your greenhouse, to your tunnel or your field, and to check the growth stage and the reaction to what you like to do. First, it's always good to have a visible check and just follow up your idea of what is the best crop has to look like. But also, I like to motivate you to use some application tools to check. The minimum, what you have to do regularly when you produce and use the dripper, measure what you will start your crop cycle and check in the drippers, in the crops, the pH and the EC. And you can do it quite easily. It's common to use just something to collect some water, and then easily in the water, which is the drained water, or you can use even and collect the water direct on the dripper. You can check if what you will apply in front of your field is really coming into the field itself. So in front of the installation, you will use your fertilizer, you prepare your stock solution, and then you apply a certain amount of fertilizer, let's say 1.2 EC of a fertilizer, to your field. Go to your field and measure with EC meter if really is 1.2 EC is measured in the field. Just collect the water on a dripper and then check it. And the second what you have to check is the amount of the drain water. In former times, there was the old-fashioned idea, give a little bit more than the crop needed. So give 20% up to 30% of drain. And even if the water is having very salty and very high EC, it's better to give more drain to keep the roots very healthy. And this rule is not bad. So if you have a bad water source with a high EC, a very salty water, it's better to apply fertilizer and on the next day just water the crop to reduce all the salt content in your soil. You can do it even on tabletops, which you will find in this overview, or you can do it as well in an open field, because always on sandy soils, you can wash out all the nutrients like sodium or chloride or sulfates, which are not really necessary for the demand of the crop feeding. And you can reduce the salt content and improve the system for the root. But you have to measure it. The minimum should be 1 time a week. It's better to do it 2 times a week or regularly overall. When you will do additional soil samples or leaf samples, you can do it, but take care and keep in mind that it's the time between harvesting the leaves and having the result from the lab. It can 10 up to 14 days after taking off the leaves. And these 1 or 2 weeks in between is a long time before you know what you have to change. So I prefer regularly revisit your farmland and check the soil parameters, EC, pH, and salt content, because you know better than anybody else what you have prepared as stock solution as nutrients and what you apply regularly by day or by week, 1 or 2 times per week or 7 times per week. Then you have a better feeling with your EC meter and your pH meter what the crop is reacting.
Thank you very much, Ralph. It was really impressive how deep you got inside and gave us a good overview about the opportunities and measurement devices, and we learned a lot. Now we are coming to the last and the 5th question, and I would like now to ask you how to check the yield and quality versus the fertilizer program. A, what should be improved for the next season? And B, which is strong and weak point of the fertilizer program?
After harvest is before sowing. After the picking, it's always recommended to summarize your program versus the yield and the quality to check what can you improve. After finishing, first check all parameters. You know how many kgs of fertilizer you have applied per hectare for N, P, K, and all other nutrients. When you will check your yield, there is a nutrient use efficiency. And there are some data available to check if your applied amount of fertilizer is fitting into your expected yield. Of course, the parameter nutrient cannot oversteer the effect of water, sunlight, and other conditions. So in cases of very hot or very cold seasons, or very dry or very watering seasons because of heavy rainfalls, this is having a high impact on your results. But also we find in a lot of cases when you will not having the best dripping system, because the dripper is having too big holes, so the application of water in 1 hour is too high, let's say 2.5 up to 4 liters per hour, that you will waste a lot of water and also nutrients, and you apply more nutrients, and of course in most cases more nitrogen than necessary, because also with the water the nutrients will flow out and you will have a loss because the water is going to a zone deeper than 1 meter where no root can achieve the nutrients and the water. In such a case, you have to rethink if it's the right scheme to apply fertilizer 1 time a week, or you will change from this drip line to a drip line with less water per hour. So it's in some crops like potatoes or corn, it's common to use drippers 0.3 up to 0.7 liters per hour, because then the risk to lose water and nutrients to wash out is much less. And also use the time between the end of picking and the new sowing or planting on your agenda to conclude what was going well and what can be improved. So is the idea to use, let's say, a small barrel of 100 or 200 liters the best idea to prepare a stock solution? Or it's better to use a 1 or 2 cubic stock solution tank to prepare your stock solution, because then it's easier to produce the stock solution. You have more time to prepare it, and you can use it, let's say, for 1 or 2 weeks before to rebuild up the stock solution. That is less work and gives less opportunities to do failures in preparing a stock solution. And always try and think about what you can do better next time. If it's just go to the field and open the magnetic valves by hand, or you can use a small computer which you will program and measure, let's say, the hours or the amount of sunlight, and to give an automatic feeding impulse. Or you will change from a model to apply 1 time a week the fertilizer by 1 or 2 bags of an NPK, and to change to a dosage by day. So that is less nutrients per day, but a better feeding for the crop.
Thank you very much. Now we have learned a lot, and I would just stressing a little bit also for you, what is the conditions? I think we should remind you, both of us, that we are talking about someone who has been starting with a new technology, that is solar irrigation, and also that solar irrigation means when only applied during daytime, that approximately only 8 hours, 9 hours, something, the pumping is working. So a little bit out of this we need to combine and to make our first experience to become a more professional farmer using this technology. But in any case, a lot of information would help us to make the right decision and to go forward. Thank you very much from my side.
Yeah, thanks a lot. Also from my side and from the side of our participants. Thanks a lot, Mr. Steubing. Thanks a lot, Bernhard Hollemann, who presented this webinar to us. Thanks a lot also for your attendance, dear participants, and that you have been with us today. If there is a need to contact Mr. Steubing or the ICL, please use the information as Ralf said before. This webinar is part of the e-learning course on solar-powered irrigation systems, SPIS, and it has been produced by the Ostfalia University of Applied Sciences on behalf of the GIZ, which is the German Development Agency. Thank you very much, take care, and bye-bye.